I can say Control Shift M, which is for piping. And then basically what you can do is you can do a select and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder, and here what I'm doing is I'm using a select where I can look at the new data frame. So let's do this, and I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4 or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it. So similarly, there is one more package called tidyr, and we'll see how we can use data manipulation done using your tidyr package.
Let's learn about the tidyr package, which makes it easy to tidy your data. And this basically helps you creating a more cleaner data, so which is easy to visualize and model. Now this comes with mainly four functions. So you have gather, which makes your data wide, or it makes wide data longer, so that is basically used to stack up multiple columns. You have spread function, which makes long data wider, that is stacking the data together, or stack if you would want to unstack the data to data and you are talking about data which has same attributes, and then your spread can spread the data across multiple columns. You have separate, which is function which splits single column into multiple columns, and to complement that you have one more function which is unite, and that combines multiple columns into single columns. So these are four main functions which are used in your tidyr package. So let's look how we work with this. So let me bring up my R Studio here. Now for this, first is, let me just clean up my screen here, doing a Control L. So I will install the package. It is already installed, but we can just do a Control Enter, and then I can say, do you want to restart R prior to reinstall? So install, I'll say okay, and it is basically going to get the package. Now it says package TIDYR, that is tidyr, has been successfully unpacked. Let's use that package with using our library function, and that was built under R version 3.6. Now I can basically start using these functions. So for example, here we are creating a data frame. So let's say n is 10, and then we basically would say we will call it wide. Now that's the variable name. I'm using the data.frame function. I'm saying ID, which will be 1 to n. So that will take the values from 1 to 10. And then these are the values which have 10 entries. So this is a vector, phase 1, phase 2, phase 3. Let's create a data frame out of it. Now that's done. We can have a look at our data frame by just doing a view wide, and that shows me the ID column, and it has phase.1, phase.2, and phase.3. Now we can use our function. So for example, we can work with gather, that is reshaping the data from wide format to long format, and basically you can say stacking up multiple columns. So let's see how we do that. Here I'll call it long. I'm working on wide. I'm using the piping functionality, and then I'm using gather. So this one, I will say what will be the data which I will use. So we are using wide as a data frame. Then I'm saying response time. So that will be basically one more column, and then you have your columns which you would want to basically stack. So I'm saying from phase 1 to phase 3. So let's do this. And once this is done, let's have a look at our variable long. So this one shows me that I have an ID column, I have the response time column, and I have the phase column, which we mentioned. And that basically has all the values stacked in. So you have phase.1, phase.2, and phase.3. So I have all the columns are being stacked here. So all my data. So now I have totally 30 entries in this one. So this is basically using your gather function. Now sometimes we may want to use a separate function. Now separate function is basically splitting a single column into multiple columns. So which we would want to use when multiple variables are captured in a single variable column. Okay, so let's look at an example of this one. So let's say long separate, that's what we will call. We will work on this long, which has all the data stacked in as the columns we selected. Then I'm saying separate. I want the face column. And then I would say, when I separate the columns, what are my column names? Now I could also give a separator by giving a comma and then mentioning the separator if that is required. So let's do this. Now, once this is done, let's have a look at our long separate. So what we see here is the column which we used. So we were doing a face column, and that was to be split. And we wanted to split it into target and number. So that's what we see here. So you have face being split into target and number, and then you have the response time. So this is how you use the separate function. Now there is also something called as unite function, which is basically a complementing of separate function. So it takes multiple columns and combines the elements to a single column. So for example, here we will call it long unite, and we will take long separate, which was separating the data. We want to unite, so we will take face, target, number, and we want to have a separator between them. So let's basically do this. And now let's look at the result of this unite. So you see, you have the face and target merged together. So you have face dot one, the separator is dot as we have mentioned, and we have united multiple columns. So this is one more function of your tidyr, which helps you basically tidy up your data or put it in a particular way. Now then you have your spread function, and this is basically for unstacking. So that is, if you would want to convert a stack to data, or if you would want to unstack the data which is of same attributes, spread can be used so that you can spread the data across multiple columns. So it will take two columns, say key and value, and spread it into multiple columns. So it makes long data wider. So we can look at this one. We will say long unite. I'm using the piping. I will use the spread function. I'll work on the face column and response time. And let's do this. And then let's do a view on this. So it tells me our data is back in the shape as it was in the beginning. So these are four functions which are very helpful when we work with tidyr package.
So let's learn about visualization. And here we will learn about R, which can be used for your visualization. Now, one thing which we need to understand is, because of our ability to see patterns, which is highly developed, we can understand the data better if we can visualize it. So the efficient way or effective way to understand what is in our data, or what we have understood in our data, we should or we can use graphical displays, that is your data visualization. So there are actually two types of data visualizations. So you have exploratory data visualization, which helps us to understand the data. And then you have explanatory visualization, which helps us to share our understanding with others. So when you talk about R provides various tools and packages to create data visualizations, and which can be used for both kind of data analysis or both kind of visualizations. So when you talk about exploratory data visualization, The key is to keep all the potentially relevant details together. Now, the objective when we talk about exploratory data analysis is to help you see what is in your data. And the main question is how much details can we interpret? Now, when you talk about different functions which we see here, such as plot, which is more for a generic plotting. You have bar plot, which is used to plot data using rectangular bars, or you can say creating bar charts. You have histogram or hist function to create histograms, where you look at the frequency of the data, or basically used to look at the central tendency of the data. You have box plot, which is used to represent data in the form of quartiles. You have ggplot, which is a package which enables the user to create sophisticated visualizations with the little code using the grammar of graphics. And then you have plotly or plotly. It creates interactive web-based graphs via the open source JavaScript graphing library. Now, before we see some examples here, let's also talk about, when you talk about plotting, let's also try to understand what kind of plots you can have and what kind of techniques you have. So let me open up my RStudio here. Now, for example, I can pull out a particular data set, and let's look at this one. So here I can look at all the panes, and that shows me the information. Now what I can do is I can install and get the inbuilt data sets, and then I can simply do a plot wherein I am doing a plot on chick-weight dataset. So let's see what does that show. It summarizes the relationship between four variables in chick-weight data frame, which is in R's built-in dataset package. Now from these plots, we can see, for example, weight varies systematically over time. You can also see that chicks were assigned to 4 different diets. Now, when we talk about explanatory data analysis or visualization, that shows others what we found in the data. This means we need to make some editorial decisions, what features we would want to highlight for emphasis, what features are distracting or confusing and you want them to be eliminated, right? So there are different ways of doing it. Now, when you talk about your graphics or visualizations, you have, I would say, 3 different types, or you can say 4. So you have the base graphics, which is easiest to learn. Now here we are having an example of base graphics where I can use the base graphics. I can get a data set using library. Then I can simply create using plot function to generate a simple scatter plot of calories with sugar from US serial data frame in the mass package, and then I can give it a title. So this is basically a simple example of base graphics. Now you also have what we call as grid graphics, which is powerful set of modules for building other tools. Now you also have lattice graphics, which is general purpose system based on grid graphics. And then you have your ggplot2, which implements grammar of graphics and is based on grid graphics. So you have different ways. Now here, since I already have used library and I have the data set, I can just do a X. So I can assign the sugar related values to X and calories related value to Y. Then I can use one more, which is library function and calling in grid. Now I can basically use functions such as push viewport if I would want to create a plot using your grid graphics to create the similar kind of plot which we created using base graphics, but this will give you much more power than base graphics. It will have a steep learning curve, but it is usually useful. So I can do this where I'm saying push viewport. Then I can basically say I would want to have a data viewport. I would say different functions of your grid package. So I'm saying rectangle, you have x-axis, y-axis, given some points here. And then basically you can add details to the graph by giving the names to the columns, and you can basically create a simple grid graphics based plot here. Now, there are different other options which we can use to create plots. Now, before we go into understanding how you create plots, let me just give you a brief on what are the different kind of plots and how they can be used. So here we will look at these different plots. Now, for example, we have a bar chart, which is a graph which shows comparisons across discrete categories. So you have x-axis, which will show the categories being compared, and y-axis, which represents a measured value, and height of the bars are proportional to measured values. Now, to create different kind of charts, you can use ggplot, which is a package for creating graphs in R. It is basically a method of thinking about and decomposing complex graphs into logical subunits, and that is a part of tidyverse ecosystem. So it takes each component of graph accesses, you can give scales, you can give colors, you can give the objects, and you can build graphs on particular data. You can modify each of those components in a way that's more flexible and user friendly. You can, if you are not providing details for the components, then ggplot will use sensible defaults, and this basically makes it a powerful and a flexible tool. Now here are different options when you use your ggplot, such as you can use geom, or what we call as geometry objects, to form the basis of different type of graphs. For bar charts, you have for line graphs, you have scatter plots, that is underscore point, you have underscore box plot for box plots, you have quartile for continuous x, violin for richer display of distribution, and jitter for small data. So here is some simple example where I would not go into too many details here, but you can just have a look at this one, where we are using library function to get the ggplot2 package. Then basically we would want to look into the mileage data. We would want to look at the structure of it. And then we can basically get the tidyverse package. Finally, we can create a bar chart using geom underscore bar, and we can basically also mention what would be in x-axis. Now you can also give different colors to basically add more meaning to your data. You could also go for stacked bar charts. So here we are actually telling ggplot to map the data in the drive column to fill the aesthetic. So here I am giving aesthetic access class, and I'm saying what is the data we need to have, and then we are using geom underscore bar. So you can also have dodged bar in your ggplot, that is not bar charts which are stacked but next to each other, and you can create that by using your position as position underscore dodge. Okay, now you can obviously use your different packages which are inbuilt, and you can create your bar charts. And you have other kind of graphs such as line graph, which is basically a type of graph that displays information as a series of data points connected by straight line segments, such as this one. And for this one we are using, if you see, geom underscore line. Now you can also create a scatter plot, which is a two-dimensional data visualization that uses points to graph the values of two different variables, one on an x-axis, one on y-axis, like what we saw in base graphics example. And they are mainly used if you would want to assess the relationship or lack of relationship between two variables. And you also have histogram, which I mentioned is mainly to look at the distribution of a data, to look at the central tendency of the data, basically looking at your large amount of data or for a single variable. You would be interested in saying where is more data found in terms of frequency, where is lesser data found in the graph, how close the data is towards its midpoint, or what we call as mean, median, mode. So you can use histogram, where you can categorize the data in what we call as bins. So these are some basics on different kind of graphs. Now we can look at some examples and see how that works. So what we were seeing is some quick examples of base graphics or grid graphics. Now here, let's do an example of pie chart for different products and units sold. So you want to create a graph for this. First, Let's create a vector and pass in the value here. Now I can also create labels which I would want to assign to these values. And then basically I can plot the chart by saying pi. So that's the kind of chart which I would want to create. And I would say the data would be X and labels. So let's do this, and that shows me a simple pie chart. Now I can also give main details here. So instead of just doing a pie X comma labels, I can say what is the main and then what kind of coloring it should follow. So this is the way you can create a simple plot. Now I can also find out what is the percentage, and then basically I would be interested in plotting the pie chart which takes X, which takes the labels, which will be the percentage which we are calculating here by doing a round function. And then you can basically give details to your graph. You can say what color it follows. You can basically look at the legend where it needs to be in your chart, what are the values, and then basically fill up the colors. So let's run this one, and that shows me the percentage which was calculated, and it gives me the details, and we can always have a look at our plot. Now if you would want to go for a 3D pie chart, then you can get the package which is Plotrix. Let's use that by calling in the library function. Let's pass in some data to X, and let's give some values or labels which will make more meaning to the data. And then let's plot the 3D graph. So I'm saying pi 3D here, where I'm using X and labels. Then I'm basically doing an explode, which will basically control how your graph looks like and basically give the values. So it also takes the title when you say main and pie chart of countries. Now let's create data for graph. So again, we are having a variable here. We are using the C function, creating a vector, and then let's create a histogram for this one, where I would say X lab, what would be your data around x-axis, what is the color, what is the border, and here I'm creating a simple histogram which, as I discussed earlier, will always show your values on the x-axis, and y-axis is more of frequency. And then you can look at the set of values and what is their frequency. And we can basically use this histogram for exploratory data analysis, look at the data, try to understand what is the central tendency of your data values. Now we can also give some limits by using the xlim and ylim, and then I can also specify what is the limit. So we have given some values here wherein we have said your x limit is 0 to 40 and y limit is 0 to 5. Now if you compare this with the previous one which we had created, this one based on the frequency had taken the limits, but we can assign limits explicitly by giving this and then create a histogram which makes more meaning. Now let's take another data set, that is air quality. Let's view this to see what does that data contain. So you have ozone, solar, wind, temperature, month, and the day. So this is the kind of information we have in the air quality. Now let's use the plot function to draw a scatter plot, where, as I mentioned, you would be interested in analyzing variables and see what is the relationship between them. So to plot a graph between ozone and wind values, so we will say plot, we will say the data which is air quality. From that I would be interested in the ozone column or ozone field and the wind field. I can create a plot based on this. Now I can also be saying what should be the color, what is the type of the data which you would want to create, and you can look at the information. So you can create a histogram, you can create a scatter plot to basically understand the data better and then infer some information from that data. So let's take the air quality data set itself without specifying any particular column, and you can create a plot which shows me all the different values which you have in the data, and it basically shows you the difference. This is more of an example like what we did for chick weight, where we did a base graphics. Now you can assign labels to the plot. So that is when you are creating a plot, you can say air quality, you will say ozone, and then that's your ozone concentration. You have your YLab, which is the number of instances. You have what is the title, ozone levels in New York City, what is the color. So these are the details what we have given with our plot function. And let's look at the data. So it just tells me that this is the ozone concentration, the number of instances what you have, and you are looking at the data. Now we could also create a histogram by picking up a particular column that is such as solar from your air quality, and that basically shows me the frequency of solar values, and we can then try to find out what is the mid, what is the mean, what is the standard deviation, and so on. You can also look at your histogram and try to understand if it is left skewed and right skewed. So we can do that. Now here, let's get the temperature out from this particular data set. Let's create a histogram on temperature, and that basically shows me the frequency of the temperature values and what values have the most frequency or most occurrence. Now you can create a histogram with labels. So let's do that with the limit, and then let's also use text to basically give in the values, which also takes the values, and for each set of frequency or each set of values it gives me the labels. Now you can have a histogram with non-uniform width, so you could do that by doing a hist function and then passing in your temperature. You can say what will be the main, what is the title, what will be your X lab. It will tell you a limit around x-axis, what is the color, what is the border, what are the breaks you would want to have for your bars, and you can simply create a histogram using this. So this basically takes the breaks which we have given, such as 55 to 60, 60 to 70, 70 to 75, and so on. So this is basically creating a histogram with non-uniform width, and it purely depends on the kind of values what you have. Now you can also create a box plot, which sometimes helps us in understanding the data quartiles, also understanding our outliers. So you can create multiple box plots based on the data from air quality. So we'll select all the data and then we'll do some slicing on the data. So let's create a box plot which tells me the values, and if you look at these points here like single dots, these are basically your outliers. We can learn about that more in later sections. So you can use your ggplot2 library to analyze a particular data set. So for that, we will first use the install.packages and get ggplot2. So it says, do you want to restart R? And I can say yes. So let it get the package. I think the package was already there. And now let's look at using ggplot2. So for that, I have the library function, and let's do a attach where I'm getting a data set which is empty cars. Now then I will create a variable p1. I will use ggplot. I will pass in my data. I'll give the aesthetics, what is the columns which you would be interested in, and then you are using geom underscore box plot to basically create a plot which gives me the box plot for the values here, and this is based on the cylinders which is there in your data. So we can always look at what does our data contain and what kind of values or features are available in the data. Now let's create a box plot. We will also use the coordinate function, and that basically gives me based on the data. So I've changed the coordinates. Now if you look at the previous one where we created a plot, we had mileage on the y-axis and cylinders on the x-axis. Now I did a coordinate flip, and that's like your transpose function. So you have created the box plot, but you have just flipped the coordinates. You can create a box plot and then say fill, which is the factor of cylinder. So that can be used to fill up the values in your box plot. Now what we can also do is we can create factors. So we have learned about factors earlier. which is usually used to work on categorical variables. So here, let's create a factor, which is empty cars gear. You have AM, you have cylinder. And if you look at the factors which we have created, we have passed our data. What is the field or the column we are interested in? What is the level of values there? And what are the labels for those values, right? So we have learned about factors. You can always look into the previous section and learn more about factors. Now let's create a scatter plot by using the ggplot function. Again, we will use the data as empty cars. I will go for mapping option, and then I will give my aesthetics. That is what would be X, what would be your Y, and you also would want to use what kind of function you are using. So let's go for geom point, and that basically helps me in creating a scatter plot. Now you can create a scatter plot by factors. So here we will say ggplot. So notice in all of these cases, depending on the kind of data you have, depending on the kind of plot you are interested in, you will use the ggplot and then basically a function with that or the inbuilt package. So here I'm saying data is empty cars. I'm going for mapping, which basically will take the values for your X and Y. What is the color? And the coloring will be done based on the factor values. Now, if you remember, factors will obviously have some levels, and those levels will basically help you in differentiating between your categorical variables. So I'm saying as dot factor on cylinder, and then I'm using geom point to basically create this scatter plot. So let's do this, and I can look at the values of this one. So it says must be, there is an error which says must at least one color from the hue palette. So let's look at that one. So the error which we were facing when we gave color as the factor values was because when you look at these factors which were created with some labels, if we look at the values of these, it tells me there are NA values in that particular column. Similarly, your gear, or similarly, you can completely look at the complete data set. It tells me cylinder, you have AM, you have gear. Now these have some, we have created some labels, but these have NA values. So what we can do is we can create a scatter plot as we did earlier by giving the aesthetics, and that's a simple scatter plot wherein I'm also using geom point so that I can have these points by defaults or with defaults. You can also give a color specific, basically if you would want to have different kind of data in the same plot, or I can create scatter plots by different sizes by giving a size, or I can give a color and size, and that's again one way in which you can create your scatter plots. Now let's also see how you can visualize one more data set, which is MPG. So I can also do it in this way where I set ggplot2 and then pass in, look at the data set what we have here. You can just do a view on this to see what my data contains, if the fields have any NA values, if that's going to affect your plotting. So now what we can do is we can create a bar plot or a bar chart. So I'm saying ggplot, the data would be as we have given in previous lines, that is ggplot2 mpg. Then I will say what should be in my aesthetics and what kind of chart are you going to create. So I'm saying geom underscore bar. So that's my bar chart, and that has basically your class and count. Now you can create a stacked bar chart where your information is stacked in the same bars, and we are still using the same data. We are going for aesthetics, which is class, and then when you say geom bar, which creates your stacked bar, we will use fill, which is drive. And we can always go back and look at our data. For example, you can always look into this. So you have the drive column here, and you are also working on this complete data set. So let's go ahead and create a stacked bar chart. And that basically gives me the information where you have the drive information, which is stacked here. Now you can do a dodge by giving the position as dodge. So we are still going to go for a stack chart, but this time the bars will be next to each other, and that can also be done, which is very useful. You can use this by using geom point, where you are mapping and you are specifying what are your aesthetics. So we were creating a scatter plot. Now you can also use or give more details, where you can say color can be based on the class, and we have different classes, and based on that my points have been colored. Now you can also use a plot ly or plotly library. So let's install this one. I will say yes, for example. Let it basically restart so that all my packages are updated. Then I can access that package using library function, and then create a variable to which you are assigning your plot underscore ly plot. So data is empty cars. What will be your x-axis, what will be your y-axis, and details on your marker which we have given, wherein I will give a list which is size, color, which is a combination, and then you have your line, what kind of color it will have, and what will be the width. So this is where I'm going to use plot ly, and let's look at this plot. So it basically gives me some information. Now we see some warnings which are getting generated, but you don't need to worry about that. So you can look at the packages, what you have, and what options you are using. So similarly, we can create one more plot using plot ly and look at the values of those. So that's a plot with a trend which explains me about my data. So this is a simple small tutorial on understanding or how you can have your graphics or visualization used to understand your data. Obviously, there are much more examples, much more ways in which you can pass into your plot functions or your ggplot and the inbuilt packages which are available in R for your visualization. Now that could be for exploratory data analysis or explanatory data analysis. So try these graphs and see if you can change these options and try or create new visualizations.
Now, let's do a hands-on project to perform a time series analysis using R programming. In this project, we'll be using time series energy data to explore the variations in electricity demand and renewable energy supply over time. Over to Ajay now.
Welcome to this session where we will learn on time series analysis using R programming language. So this is basically a mini project where we will look at time series data and how we can analyze it, visualize it to basically find some important information or gather insights from the data. Now, when you talk about time series analysis, time series is basically any data set where your values are measured at different points in time. So when you talk about time series data, data is usually uniformly spaced at a specific frequency. For example, hourly weather measurements, you have daily counts of website visits, monthly sales total, and so on. So when you talk about time series, that can also be irregularly spaced and sporadic. For example, timestamp data in computer systems, event log, or history of 9/11 emergency calls. Now, when we work with time series data, for example, here I'm taking an energy data set, we can see how techniques such as time-based indexing, resampling, rolling windows can help us explore variations in electricity demand and renewable energy supply over time. Now, here we will look at some aspects of this data set which I'm considering. So this is open power systems data set, and here is the data set I have. We can look at the data set. Now this is in a simple format. It has time. It basically has values for consumption, and then you have data for wind and solar and wind plus solar. So in certain cases you have only the date and the consumption. But then if we scroll down, we will also find data for wind, solar, wind plus solar, and so on. So this is a time series data set which we would want to work on. Sometimes you may also have the data collected which just does not have the time, but it may also have timestamp, that is, it would have, say, hour, minutes, and seconds, and that can also be worked upon. So let's consider this data set and let's work on this project where we will analyze this time series data set. Now here we can work on this time series data. We can basically create some data structures out of it, such as data frames. We can do some time-based indexing. We can visualize the data. We can look at the seasonality in the data, look at some frequencies, and also do some trend detection. Now, when you talk about this data set, it has electricity production and consumption, which is reported as daily totals in gigawatt hours. And here are the columns of the data, which I was just showing you. So you have data, you have consumption, you have wind, you have solar, and wind plus solar. So this is the data we have, and we will basically explore, say, electricity consumption and production in Germany, which has varied over time. So some of the questions which we can answer here is, when is electricity consumption typically highest and lowest? How do wind and solar power production vary with seasons of the year? What are the long-term trends in electricity consumption, solar power, and wind power? How do wind and solar power production compare with electricity consumption, and how has this ratio changed over time? We can also do wrangling or cleaning of this data or pre-processing of data and create a data frame, and then we can visualize this. Now let's see how do we do that. So I will open up my RStudio and let's look at the data set. So here is the data set. Now I'm picking it up from my machine. You can also pick it up from GitHub. So all the data sets or similar data sets can be found in my GitHub repository. And here I can look in the data sets. You will find a lot of different data sets here. There are some time series data sets such as power. I can search for power, or you have basically coal, or you have this OPSD Germany daily data set, and there are many other data sets which you can work on. Now, to get the documentation on this project, you can also look in my GitHub repository and you can search for repositories, and then basically you can look in data science and R, and here there is a project folder where I've given the documentation, sample data set, and also your time series analysis related document. This is also the code which you can directly import in your RStudio, and you can practice or work on this project. So let's see how does that work. So first thing is, we will create a data frame from this data set. Now here, if you see, I am using header as true so that it understands the heading of each column. I'm also giving row.names and I'm specifying date. So there is this date column in the data set as I showed you earlier. Let's look at it again. So you have date, consumption, wind, solar, wind plus solar. So you can suggest that date should become the index column, which can be useful. So you can do this. Now let's just create this. Let's look at what does this data frame contain. And here, if you see, it shows me some data which has been now as a part of this data frame structure. It starts with consumption, wind, solar, wind plus solar. And if you see, this one is becoming my index column. So I can always do a head and look at part of the data frame using head or tail. So look at the first records. So let's see this. Now that shows me the head data. I can also do a tail and look at the ending values. So if you closely see here, we have wind, solar, wind, dot solar, and that basically has NA values. So there are missing values, but let's look at the tail, and that tells me that there is some data available for wind and solar and wind solar. Now we can always look in a tabular format using view, and we can look at the data. So this shows me that there are values in these columns. We see NA values, but if I really scroll down, I can see some values which would be available for wind and solar and wind solar. So I can just use view. Now I can look at the dimensions of this particular object, and that tells me there are 400 4,384 rows and 4 columns. You can always look at the structure, that is check the data type of each column, which can be very useful. So if I see here, I don't see the date column because date column was considered as an index, which can be useful. But I also look at my other columns, so they are of the num types. So that's the data type for each attribute or each column here. Now we would be interested in looking at this date column. So let's look at the data type of this date column. Now if I try to do this, this will show me that this is null because date as a column does not exist because we created it as an index. So if I look at row names and then I search for my data, show me the index column or row dot names, it tells me these are the values, that's the date column, which we are seeing here. Now we can access a specific row by just doing a my data and give the index value or row name value. So let's look at that, and that shows me based on this index you're looking at the value. You can obviously search for a different date, something like this. You can also pass in a vector and you can give range of values, so that is 0, 1, 2006 to 4 of January, and we can look at this one. So it shows me these are the values. So here actually I'm not giving a range, but I'm just selecting multiple values from row dot names. Now we already know that in R you have a summary function, so you can always do a summary, and that gives you for each column, it gives you minimum, first quartile, median, mean, third quartile, and maximum values. So we are looking at consumption, we are looking at wind, solar, and wind dot solar. Now this is good, but then if I would want to really visualize the data, access the data, do some analysis, then it would be good to take all the columns, and then we can later decide to change the data type of, say, date column if we want to use it. So earlier I was using date as row dot names or the name of the rows or index, what you call in any other programming language. So here I will just use my data set and I'll say header as true. I'm calling it my data 2. Let's look at the data, and this one shows me 5 columns, wherein my first column is the date, consumption, wind, solar, and so on. Now looking at the structure, so let's look at the data type. So it tells me that if now I'm interested in looking at the date column from my data to data frame, it tells me it is a factor with 4384 levels, and these are the values. So it is not in a date time format, it's a factor. Now what we can do is we can convert this into a date format. How do we do that? So let's have a variable x, and I'm going to use as.date function, and I'm going to pass in my date column. So that's assigned to x. Now let's look at the head of x, and it shows me the values. We will also see what kind of class it is, and we will look at the structure of x. So class already says it is date type, and look at the structure, so it shows me the format. Now we have converted this column or column related value into x. Now how do I basically extract values out of it or make it a part of data frame? So first I will use, so all once it has been converted in date format, I will go for as.numeric, and here I will create a variable called year, and I will just do a format on x, which is basically of date type, and then I'm saying %y, so that will get me the year component out of this. Let's look at the values. That shows me year component. Now similarly we can get the month out of this, and then basically look at the month values. We can get the day out of it, and we can get the day component. Now if I look at my data 2, which we had created earlier, this basically had date, consumption, wind, solar, wind, solar. So what I can do is I can add these extracted columns such as year, month, day to my data frame using a cbind, that is column bind, and I will assign it to my data 2 again. So let's do this, and now if you look at head, it shows me date, So that should be date format, consumption. Now this one might not be date format, but we'll see. You have consumption, wind, solar, and we have extracted the year, month, and day, which can help us for group by. We can do some aggregations, we can do a plotting, and we can do various things by these additional columns. Now let's look at first 3 rows here. So I'll say 1:3 for my data 2, and that shows me some data here. You can always do a head and look at the sample of data. So that basically shows me month, day, your columns, and then you have your date. Now, what we can do is we would want to visualize this data. We would want to basically understand the consumption. Now, as I said, if we want to visualize the data, say for example, I want this, which is consumption of data over years. And this one is in terms of gigawatts per hour, as we were mentioning here, gigawatt hours. So if I would want to create this visual to basically understand the pattern of the data, how do we do it? So we can create a line plot of full time series of Germany's electricity consumption using the plot method. Now, how do we do that? So here, one of the option is I can straight away use the plot method. I can then say what would be in my x-axis, what would be on my y-axis, what would be the type of graph I would want to plot, what is my name on x-axis, y-axis, and this is the simplest way. So I'm saying my data 2, I'm extracting the year column, and here I'm taking the consumption. So let's create a plot. And here, if you see, we are looking at a plot. We do see some tick times, and we see that the data has been divided with every 2 years. So from 2006 onwards to 2016. But then really this data does not give me a very useful way of looking at the data or understanding it. Might be what I can do is I can use the same way, but I can give, apart from x-axis and y-axis, I can say the limits, that is x limit is 2006 to 2018 and y limit is from 800 to 1700. So we can do this, and let's look at this again. This is a plot, but it really does not help me in visualizing and understanding the data. So what are the better options? I can go for multiple plots in a window. As of now, we are just sticking to one plot in window. So if you would want to have multiple plots, you can always change the value here and make it 2 or 3. That will say how many rows and how many columns. So as of now, we will just keep it as it is, par mf row. Now, if I would want to plot, I can straight away give the column name. So I am interested in getting the consumption. Now I can just do a plot. I'll say my data 2, and I will choose the second column, which is consumption, which we saw here from our data. So consumption was the second column. So I can just do a plot in a straightaway way without mentioning your x-axis, y-axis, limits, and so on. And if you look at this one is giving me a pattern. Now here I am looking at x-axis, y-axis, which is not really named. We do not have a name to this graph, and we are looking at the data. It does show me some kind of pattern, but might be we can make it more meaningful. So I can do it this way, where I say my data second column, let's give axis as year, x-axis, y-axis is consumption. Now that has changed, the x-axis and y-axis. Now I can also give some more details. I can say type should be line. I have the line width. I'm saying color is blue. And let's do this. So this looks more meaningful, might be shows a wavering pattern of consumption over years. I can also give a limit of X, that is 0 to 2018, and that basically shows me the range. Now we can change that, and we can be more specific and saying X limit should be 2006 to 2018. And let's look at this. Now this one, once you have given a proper limit, it shows the line graph, and it shows what was the consumption in 2006 and over a period till 2018. I can then use any of these options are fine, but it depends on what and whom you are presenting the data or what kind of analysis you're doing. So I can do a plot. I can choose column second, X lab, which is X-axis, Y-axis, type is line, width, giving a X limit, Y limit, and then I'm giving a title to this, which is consumption graph. And then basically you are looking at the line graph. Now, those are the options which you can do. Either you could be very specific, or you could just give your column which you want to plot, or obviously make it more meaningful by giving all the details. Now, what we can do is, if we would want to look at this data and understand it better, rather than just looking at a simple line, I can take the log values. So here I'm saying log of my data 2 second column. So I'm taking log values of consumption and I'm taking the difference of logs. So I can say difference, and then you can basically increase or decrease this by multiplying it by some number. So rest remains the same. I'm changing the color, and let's look at this plot. And you see, this basically is giving me a better pattern, which makes meaning. Here we see the log values. So this is, you are using a simple plot function. In R, you can also use ggplot. Now for that, we can install the ggplot package. It's already there in my machine, so I'll say no. I will access this by using the library ggplot2. And now I can use ggplot to plot. So the way you specify here, you can say my data 2, that's the data frame. I'm saying type as O, and when I'm saying line, I am basically going to use x-axis, which is year, y is consumption. And let's look at this plot. So again, we are back to the one which we were doing earlier. Really does not make any sense. It gives us some data, but then really does not give me enough information. I can, in my aesthetics, I can say X as year, Y as consumption. I can do a grouping, and then I can give line and plot. So again, we have some information, but really does not help me, right? Now let's look at other example. So I'm just doing the same thing here, and I'm looking at line type being dashed. I'm using the ggplot's other methods such as geom line and geom point to give me more information. And if I look at the plot, it does give me data. It tells me what are the different values. It gives me some kind of pattern, but I would still prefer the way we were doing with plot. Now we can change the color and obviously add details to it. So what we see is, when you use the plot method, which I did earlier, it was choosing pretty good tick locations, that is every 2 years, and labels the years for the x-axis, which was helpful, right? But with these data points, which we were seeing here, or say, for example, this one, or say this one, or say this one, we are looking at some data, but then that really is quite crowded and it is hard to read. You can look at the values, but then it really does not give you enough information. So we can go for plot method, but then we will see how we can consider different data. Now, if I would want to plot the solar and wind time series, so let's see how do we do that. So wind column is what I'm interested in. So first thing is, it was always good to find out the minimum and the maximum values in every column. So I'm saying minimum. I'm saying let's put in here my data 2, and then let's look at the values. So we are looking at the columns. We know consumption is the second column, wind is the third column, and you have solar as the fourth, and this one is the fifth. So let's say, let's find out the minimum of each of these columns which we would want to plot. So let's say minimum of data third column. And here I'm also saying remove the NA values, because we do not want to consider the NA values. So let's look at the minimum. That shows me 5.7757. What is the maximum value? It is 826. So that also helps me in giving a limit. If I want to plot wind on y-axis, I can give a y limit from 5 to 850. Consumption wise, let's find out the minimum from second column and maximum. And similarly for solar, find the minimum and maximum, and wind plus solar, minimum and maximum. So this will be helpful when you would want to plot multiple graphs or give some limits. So that's fine. Now for multiple plots, as I said, instead of having one plot, let's plot consumption and wind and solar and try to see a pattern. So I can say par function, and I will say 3 rows and 1 column. So now when I start plotting, you will see you will